This is Geometry, section 3.4, Parallel and Perpendicular Lines. So in this section we've got a couple theorems that are basically an extension of the transitive property, except using parallel and perpendicular lines. So the first one is if we have two lines that are parallel to the same line. If I've got three lines, and I've got this line in the middle is parallel to this line, and this line on the bottom is also parallel to that middle line, then those two lines, the top and the bottom, are parallel to each other. It's pretty obvious. Like I said, it's sort of like the transitive property. If I call this line A, line B, line C, if A is parallel to B and C is parallel to B, then A is parallel to C. All three lines are parallel. Pretty obvious. So determine any and all lines that are parallel to each other. Here we've got a 78-degree angle right here, which would mean we have 78 here. 78 here means 78 here. I'm just filling in our vertical angles. 102 here would mean 102 here. These two angles are same side interior angles, so we could check to see if these are supplementary to see if A and B are parallel. 78 plus 102 does give us 180 degrees. So A is parallel to B because our same side interior angles are supplementary. Same thing here. We've got the same two angles, 102, 78. Those are supplementary. Those are in between B and C, which means that B is also parallel to C. So A, B, and C are all parallel to each other. Same situation here. We've got filling in our vertical angles. We've got 100, 80, 100. Same thing here. These same side interior angles in between X and Y, and these same side interior angles in between Y and Z are all supplementary to each other. So since our same side interior angles are supplementary, X is parallel to Y, which is parallel to Z. Second theorem we have is in a plane, if two lines are perpendicular, we're going to use this upside down T symbol for perpendicular, just like we use two slashes for parallel. So upside down T means perpendicular. So if two lines are perpendicular to the same line, so let's see what that looks like. If I've got perpendicular lines like this, so I've got this line, we'll call it A, is perpendicular to, we'll call it B. So if A is perpendicular to B, two lines perpendicular to the same line. So A is perpendicular to B, and we need another line perpendicular to B, we'll call it C. So if A and C are both perpendicular to B, then A and C are parallel, not perpendicular, parallel to each other. So if A and C are both perpendicular to B, then A perpendicular to B, C perpendicular to B, then A is parallel to C. The reason why is because if this is a 90-degree angle, this is 90 degrees, this is 90 degrees because those are perpendicular. These are our same side interior angles. They add up to 180. So since same side interior angles are supplementary, these two lines are parallel. We could use the same concept using corresponding angles. If this is 90 and this is 90, these are corresponding angles. They're congruent, therefore the lines are parallel. So determine which, if any, lines are parallel. We're given that measure of angle 8 is 90. So this is a right angle right here. And we're given that 5 is supplementary to 8. 5 being supplementary to 8 means that these have to add up to 180. So if 8 is 90, 180 minus 90 leaves us with 90 again. So angle 5 also has to be 90. These two lines, M and N, are both perpendicular to K. We just said that that means that M is parallel to N. If they're perpendicular to the same line, they're parallel to each other. Now we've got angle 6 plus angle 2, measure of angle 6 plus measure of angle 2 equals 190 degrees. Well, these are same side interior angles, so if these two lines P and T are parallel, that would mean these same side interior angles would have to add up to 180, not 190. So since this is not equal to 180, P is not parallel, so we're going to draw parallel, the two parallel lines with a slash through it to mean not parallel. So P is not parallel to T. One more theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So this is basically the opposite of the one that we just had. we have in a plane if a line is perpendicular to one of two parallel lines. So we're starting with parallel lines. So we've got two parallel lines, and we've got another line. So if a line is perpendicular to one of two parallel lines. So we've got, we'll call this line, this vertical line A, and horizontal lines B and C. So if A is perpendicular to B, A perpendicular to B, and B is parallel to C, then A also has to be perpendicular to C. So if A is perpendicular to B and B is parallel to C, then A is perpendicular to C. So determine if line S is perpendicular to line T. Well, we've got two parallel lines. We've got S is perpendicular to R, and R is parallel to T. So that's the theorem we just said. If these are parallel and S is perpendicular here, if this is a right angle here, this corresponding angle would also have to be a right angle. So yes, S is perpendicular to T. This next one says 2 is complementary to 1. So that means that these two angles together add up to 90 degrees. So this whole angle right here is a 90-degree angle. So this is a 90-degree angle right here. Again, R is parallel to T. So this corresponding angle would also have to be a right angle. And again, S is perpendicular to T. This one, we're not told if R is perpendicular to T this time. We are told that this is a right angle, but we don't know if these two lines going up and down are parallel. But we do have these same side interior angles, 70 and 110, here and here, in between these two lines that we think might be parallel. So if 70 plus 110 adds up to 180, which it does, that means these same side interior angles are supplementary, which means that these lines are parallel to each other. So since I've got parallel lines, this line is perpendicular to one of those parallel lines. It has to be perpendicular to the other. So yes, again, S is perpendicular to T. Over here, same situation. I've got one right angle. Now I have to decide if S is also perpendicular to T. It's already perpendicular to R. I have to decide if it's perpendicular to T. So again, I have to know if R and T are parallel. Well, over here, I've got an 80-degree angle here. Then this corresponding angle is 84 degrees. So the corresponding angles are not congruent here, which means that these lines, R and T, are not parallel. So R is not parallel to T, which means that S cannot be perpendicular to T because it's perpendicular to R, and this would not be a 90-degree angle since these are not parallel lines. So here, S is not perpendicular to T.